So today we're going to look at proving identities. You don't have to follow these steps. I just find them most easier when I look at trying to make everything into sine or cosine if I can. Think about substituting any identities you can. And then I usually try to start with the more complicated side, but it doesn't matter because if they're equal, it's kind of whatever side you see it, okay? So if I try and do this one, okay, if I'm going to go by the guidelines of put everything into sine or cosine, then I'm actually going to look at this side because I do not see sine or cosine at all. So I know that tangent is the same as sine over cosine, and I know that secant is the same as 1 over cosine. Now, use this side to guide this side. What do I still need? Well, I need a sine on top. If I multiply straight across, sine of theta times 1 is sine of theta. Cosine times cosine is cosine squared of theta. And now I can see that I'm really close to this side because I know that the identity of cosine of theta squared is the same as 1 minus sine squared of theta. And I proved it to be equal. Now, notice, did I touch this side at all? No. So you can only pick one side to prove. Do not undo both sides at the same time. So once you pick a side, stick to that side, but use it as a guideline. Okay? Let's try another one. The cotangent of x equals cosine of x times the cosecant of x. So again, it's up to you what side you pick. I'm just going to go with the right-hand side this time. This is already in terms of cosine, so I don't need to do anything. Cosecant, I know, is the same as 1 over the sine. And if I put this over 1 and reference my left-hand side, my goal is to get to cotangent. Well, if I multiply straight across, and I know that cosine over sine is the same as cotangent, and I'm done. Okay? All right, when do things get a little bit more complicated is when we start seeing things with adding and subtracting in them, and they do not have squared. So 1 plus cosine of x is not the same as 1 minus cosine squared of x. This is just more in that linear form versus quadratic. So what I want to do is I want to remind you of what it is like to add fractions. If I have 4/3 plus x over 3, my common denominator is 3. And what do I do with the top? I add them together. 4 plus x is 4 plus x, and that is done. Now, if I started this way, could I split them up and go backwards? Yes. That's the same situation right here. 1 plus cosine of x, I could split that back up, and this is the same as 1 over cosine of x plus cosine of x over cosine of x. Now, look at the right-hand side. Somewhere I need a plain old 1. Well, now, cosine divided by cosine is 1, and I need a secant, but I know that the reciprocal of cosine is secant, and I'm done. All right, let's try another one. Sine squared of x plus 7 over sine squared of x plus cosine squared of x equals 1 plus 7 cosecant squared of x. All right, this looks complicated, doesn't it? Okay? Now, in order to add fractions, I have to have common denominators. I'm going to try to avoid that if possible. But does everybody agree with me that 4 plus 3 plus 5 is the same as 5 plus 4 plus 3? We can change the order. Well, look what happens here. I'm going to use this, and somewhere I need a 1. Well, one of the most common identities that kids forget is the very first basic one right here. Sine squared plus cosine squared. That equals 1. Now, what else do I need? I need a 7 times the cosecant. Well, I have a 7 here, but I know that sine's reciprocal is the same as cosecant. So I can split this up and multiply this by 1 over sine squared of x, and now flip to the cosecant. And now I have one side equal to the other. So it's kind of like a puzzle. Okay? Alright, I'm going to give you one that you can try on your own. Try it, pause the video, and then come back and see if you've gotten it right. So give this one a try. Alright, I always look to see if I ever have a combination of a 1 plus something squared, because that comes from our trig identity list. And 1 plus cotangent squared is the same as the cosecant squared. And why does that help me? Because the reciprocal of cosecant is 1 over sine squared of theta. Okay? Alright, hopefully those have made sense to you. We're going to get into a couple more that are a little bit more complicated. Again, when we're proving, we want to pick the more complicated side, if possible. And when we add fractions, we have to have a common denominator. Well, we do not have a common denominator right now, because this denominator is 1 minus the sine of theta, and this one is 1 plus the sine of theta. Okay, the other problem is just because there's a 1 here and a plus or a minus, it is not an identity because it is not squared. So if you think back to fractions, if I had 4/5 plus 3/4, I need a common denominator. So I would multiply the 5 by the 4 over 4, and I would multiply 4 by 5 over 5. So I would have 16/20 plus 15/20, and now I can add straight across. So that's exactly what I need to do here. I need to multiply the top and bottom of this by 1 minus sine of theta over 1 minus the sine of theta. And I need to multiply this side by 1 plus the sine of theta over 1 plus the sine of theta. So now on top, I have 1 times all of this, which is still the same, over 1 plus the sine of theta times 1 minus the sine of theta, plus 1 times all of this, which is the same, over 1 plus the sine of theta times 1 minus the sine of theta. So now I have a common denominator. Now that I have a common denominator, okay, I can add my fractions together, my numerators. So when I add 1 plus 1, I get 2. Positive sine of theta minus sine of theta that's it. So now all of that on my numerators just cancel. My denominators, though, I need to actually take, because this is what I have right now, I need to take and FOIL it out. So when I FOIL, I get first, outer, inner last. My outer and my inner cancel, so now I have 2 over 1 minus the sine squared of theta. Now remember, if you still don't know what to do, what is our goal? Our goal is back over on this side. What do I need? 2 times the secant of theta. Well, I still need to keep going over here. What do I know that 1 minus the sine of theta squared is equal to? That is the same as cosine squared of theta. And now I'm able to take the reciprocal of cosine and change that to secant. And I'm finally where I need to be. Alright, I have one more complicated one. We are going to take and rewrite this as tangent is sine over cosine plus cotangent, which is cosine over sine. And now we have a very complicated fraction right now. I'm just going to ignore that one on the top and I'm going to focus on this bottom part. If I need to add these fractions, I need a common denominator. So I need to multiply the top and bottom here by sine and the top and bottom here by cosine. So now I have sine squared plus cosine squared of theta all over sine times cosine. And again, we've talked about the most common mistake kids forget about is sine squared plus cosine squared is the same as 1. Now, don't forget, all of this was over 1 again. So this is the same as saying 1 divided by 1 over sine theta cosine of theta, which we multiply by the reciprocal, and 1 times sine of theta cosine of theta is sine theta cosine of theta, which is exactly where we want it.